So liming, just a little bit about liming. I mean, smaller the particle size, the faster it reacts. No brainer. Higher surface area, more reactivity. So these mesh sizes, smaller the mesh, the smaller the particles are. And this mesh just basically means there's 100 openings per square inch. So the smaller you get, the higher the number, the smaller the sieve size. Now, Oregon, whenever you buy lime, it has a Oregon lime score, and part of this lime score incorporates efficiency of different particle sizes. And recently, when we were kind of looking through the archive, we finally found out where these estimates came from. They came from this extension publication from 1955 that had these estimates, and that's where OSU got their estimates. But so a lot's changed over 50 years. There's now a company out there, Microna AgLime. They have some new technologies that are creating very fine liming materials. And so you got your Microna AgLime. This is sold as Access Lime. So it's finer than the AshGrove AgLime, which is AshGrove AgLime is pretty much, if you're liming your field, it's probably coming from AshGrove, which is up on they're producing it up by Sauvie Island out of Portland. So these two materials, even though they're different in size, 30 micrometers versus 110, they have the same lime score. So we had the question, do our guidelines adequately predict the performance of these finely ground products? So look at this. We did a number of trials. We had a large plot field trial. This was a replicated trial on a wood-burn soil. Each plot was about a 1/3 acre in size. We did a small plot trial at the research farm, and these were just, again, very small. We did in-field incubations. So this is kind of like the ideal scenario where you have sieve soil, thoroughly mixed lime, and this can give you a really good idea of performance. And then we also did these lab incubations, and I'll kind of talk about all these results. So in the large plot field trial, we actually looked at more products than I'm just showing here, but these are the two products of interest for you. Also, I'm just picking a little bit of data. Like all our research data is available on OregonVegetables.com at the OPVC site, so if you want more information, go there. But in general, in this large field plot, we saw basically no difference between the AshGrove material and Microna material. Yeah, there was a little bit of a difference at 6 months, but not at 1 and 3 months. And also, this is an ongoing study. This is going to go on for a year. So right now we're 6 months in. So no difference in this large plot field trial. In our small plot field trial, again, 1 month, 3 months, 6 months, there really was, I left out the error bars just for ease of viewing, but there was no statistical difference between the products over the 6 months in this small plot field trial. In the in-field incubation, there was this statistical difference between the two products at 1 month, but that disappeared at 6 months. And one thing to notice is the pH level. So we're using the same soil. In this small plot that we're using in the incubation study. And in the small plot, the maximum pH we're getting to is about 7. But in this field incubation, we're getting up to like 7.6, 7.7. And that's just because even we had very thorough mixing. It's just, it points to the importance of mixing your lime. Because if you take a soil sample and you see lime in your soil, that's unreactive and it's not contributing to increasing the pH. So really, it's about getting that lime mixed in if you want to get it to react and get the soil pH up high. We also, in this in-field incubation, we did different particle sizes, looking at efficiency. And again, the Oregon lime score is about efficiency at 1 to 3 years. And right now, we're just at about 6 months. Oregon OSU says that a particle size greater than 40 should be 100% efficient in 1 to 3 years. Well, at 6 months, if you look at the trajectory, if it keeps reacting the same way, it looks like it will be 100% efficient in 1 to 3 years. And so this is just basically saying that Even though a lot of this research that we based our efficiency on was done in the early 50s, not much has changed. We did some lab incubation, so those of you as a kid that made like volcanoes, we took baking soda and you added some vinegar and it bubbled up. Since it's kind of the same concept, you got carbonate reacts with acidity and you get evolution of CO2. So in the lab, we added lime to dry soil, and then we were measuring basically the CO2 that was coming off of these samples. So I'm just showing you again I'm cherry picking data. This is just one soil out of 3. Yeah, there was a difference at 1 month between AshGrove and the Microna product, 75 versus 63%, but that didn't hold in all the soils. This is only one that had a statistical difference between them. What's key to note is that we're saying that reactivity happens in 1 to 3 years. Most of these products, these powdered lime products, they're reacting within hours actually. I measure after, this is like 2 hours, 10% is already reacted. Within a day, you've got 40% of that material reacted. But it has to do, again, completely with mixing. In the lab, we get really good mixing on sieve soil. In the field, you're not going to get as fast reacting because you're not mixing it as well. So in conclusion, even though we're going to look at this over a period of a year, it just says that not much has changed in, 60 years in terms of reactivity of lime. In the short term, the finer products will react quicker. It's obvious. You got these smaller particles, they're going to react quicker. But in longer term, they're not going to have as much benefit. And again, Oregon's lime score is meant not to predict short-term reactivity, but long-term reactivity. Thorough mixing is critical for fast reaction. Over the long term, particles less than 100 mesh have the same efficiency. So yeah, finer does get you faster reacting in the short term, but over the long term, these particles that are a little bit bigger catch up. And while we're on lime, I'm just going to briefly mention about the S&P buffer test. I know I've heard people not have much faith in it or just question whether it's accurately modeling what's happening in our soils. And a lot of what we know about the value of the S&P buffer test comes from work that was done in the 70s. And on the bottom axis here, you have buffer test lime requirements. This is what the S&P buffer would tell you need to put on. This is in weird units. If you divide everything by 2, that gives it to you in pounds or tons per acre. And then you have your incubation pH is what you actually measure. The closer that these points are to the line, the better the S&P buffer does in predicting how much lime your soil needs. And this was done with valley floor soils, hill soils, so Woodburns, Daytons, Amities, Jories. I'm not sure what the wind deposited were, but Salem soils are kind of weird. They kind of deviate from the model. Salem soils, they require tons of lime and just don't behave like others. But basically, in general, this is what this is saying is that for our soils, our acid soils that tend to have a higher CEC, the S&P buffer test does pretty well. I know Western Washington is working on identifying a buffer test that'll work well with their soils, and they found that the S&P buffer doesn't do a very good job on their soils. So they have different mineralogy, different cation exchange capacity. So the S&P buffer test works best, again, when you have acid soils. Your target pH isn't too high, 6.4. And then also when your CEC is high. So if you have a sand, so in your Hermiston area, they recommend using a quarter strength S&P buffer test. In the valley here though, even our Newburgh sandy soils, the S&P buffer test predicts pretty well what the requirement is. And Newburgh was in this data set. So overall, what I'm trying to say is that no test is perfect, but this test does a pretty good job. And it's a quick test. There are other lime requirement tests out there, but none. But this works pretty well. Questions about S&P buffer at all? So coming soon. So we've got a new